All right, good morning. This morning we're going to be talking about greatest common factor. And we're going to also define least common multiple because that's tomorrow's lesson. So today our objectives are, I can define multiples, least common multiple, greatest common factor. I can use factor trees to find the greatest common factor. And I can list multiples to find the LCM or the least common multiple. All right, you should have in your notes this piece of paper that you're going to take notes on what is least common multiple and greatest common factor. That was a lot of noise. Sorry about that. Okay, least common multiple. All right, least common multiple. I don't know why it keeps doing that. There we go. Let's talk about greatest common factor first. The greatest common factor is a number that is a factor of two or more numbers and the greatest in common of factors of two or more numbers. So GCF stands for greatest common factor. Greatest, the biggest. If you think about being the greatest in the world, you're the greatest. You got the gold medal. You're the champ. You're the biggest. Common. Same features among several numbers. If you have something in common with someone else, you share the same love for something or like for something. Maybe you really like Nikes and your friend really likes Nikes. That's something you have in common. Common is something that two numbers share alike. And factor, a number that can be multiplied by another number. All right, LCM stands for least common multiple. The smallest, least, the smallest. If you weigh the least, then you weigh less than everyone else. Common, again, same thing, having something in common with another number or another value. If you share things in common with someone, you're probably friends with them because you share the same likes. Multiple, a product of a number and any whole number. So multiples of 5 would be 5, 10, 15, 20, and so on. All right, make sure you pause right now so you've got these notes when we move on. Okay, we're going to look at greatest common factor. Now, yesterday I told you that this is a way that you can write factors, the factors of 10. Now, in this example, they're talking about there's one slice servings of 3 different types of cake on the table, and each row has an equal number of servings and only one type of cake. What is the greatest number of servings in each row? So there's 3 different cakes on the table. Each row has an equal number of servings and only one type of cake. So what's the greatest number of servings in each row? So if we want to keep that equal crossed, we need to figure out the fact it looks like we've got 10 servings of marble, 15 servings of red velvet, and 20 servings of chocolate. So we're going to go over here and we're going to list those factors, okay? So the factors of 10 are 1 times 10 and 2 times 5. The factors of 15 are 1 times 15 and 3 times 5. Notice how they separate them out. Factors of 20, 1 times 20, 2 times 10, 4 times 5. Okay? So if we look in these 3 rows, what do we have in common? Well, we have a 1 in common, but is that the greatest number in common? Let's see, I got a 2 here, but no 2 here, so that's not common. I've got 5s in common. Is that the greatest number? Well, let's keep looking. I've got 10, but I don't have a 10 here. And that's the end of this row. So my greatest common factor is going to be 5. Because 5 is the greatest number that all 3 of those have in common. All right. Let's go down just a little bit here. Here's another example. Lena earned $49 on Friday, $42 on Saturday, and $21 on Sunday, selling bracelets. She sold each bracelet for the same amount. What's the most she could have charged for each bracelet? Okay, so let's list the factors over here on the right. We got 49. All right. What would be the factors of 49? Well, I know that 7 times 7 is 49. And I know that 1 times 49 is 49. You know what? We don't even need that extra 7 because we only need to write 1. So we'll get rid of that. 2, nope, it's not even, so it can't be 2. 3, no, 4, nope, looks like that's it. 1 times 49 and 7 times 7. So let's look at 42. Well, we got to have 1 and 42. Better write that over here. It's going to be a little sloppy for a minute. And 2 times, let's see, 2 goes into 4, 2. 2 times 21. And 3, no. 4, no, because 4 times 5 is 45. 5, no, it's not. It doesn't have a 5 or a 0 at the end, so it can't be a multiple of 5. How about 6 times 7? All right, and 21. Well, we got 1 and 21. 2 can't because it's not even. And 3 times 7. And 4, no, because 4 times 5 is 20, and this is 21. 5, no. 6, no. And 7. Okay, so if we look here, all we got here is a 1 and 7. So it's either going to be 1, or we got a 7, and a 7. So if she earned $49 on Friday, $42 on Saturday, and $21 on Sunday, and she sold each bracelet for the same, what did she have to sell them for? $7. All right, moving down. And again, if you need to pause and back up, because I'm going a little quick for the sake of time to be able to upload these onto YouTube for you to be able to watch them. So please feel free to back up, watch again, pause, so you can write things down, okay? All right. Over here, and I'm going to erase this real quick. So again, if you need to pause, do that now before I erase. All right. Down here we have those factor trees that we did yesterday. I think this is a much easier way to find the greatest common factor because it keeps it nice and clean. Okay? So it gives us an example here of the factor trees that we did yesterday. To find the greatest common factor of two numbers, you're going to create those trees, and all you're going to do is circle those things that are in common with both numbers. And at the end, you're going to take one of each of those numbers. So you got 3's in common and 2's in common. And when you multiply them together, you get 6. And that is your greatest common factor.